Good day everyone, I am Pedro from BSCS-4A and today I am presenting to you my video about data exploration. The code prepares the iris dataset for analysis by loading it, creating a pandas data frame and replacing numerical species codes with their names Setosa, versicolor, virginica. The import suggests further visualization steps are planned. The image shows a portion of a table representing the iris dataset. There is no code to explain. The image only displays data. The table shows the first 5 rows of the dataset with the following columns: sepal length in centimeters, sepal width in centimeters, petal length in centimeters, petal width in centimeters, the species of iris, in this case all Setosa. The data is likely extracted from a larger dataset and displayed as a preview. The Python code loads the iris dataset, converts it to a pandas data frame, adds a species column with descriptive names instead of numerical labels, and then displays the first 5 data entries. It uses pandas for data manipulation and imports visualization libraries, Seaborn and Matplotlib, but doesn't actually create any plots. This output shows the first 5 iris flower samples with their sepal and petal measurements and the corresponding species. The numerical labels have been successfully replaced with the species names. The code itself doesn't generate any plots because the Seaborn and Matplotlib libraries are imported but not explicitly used for plotting. The code generates a 2x2 grid of histograms visualizing the distribution of 4 numerical features: sepal length, sepal width, petal width from the iris dataset using Seaborn's histplot function. The KDE equals false parameter ensures only the histogram bars are displayed without a kernel density estimate curve. The output is a figure containing 4 histograms, one for each numerical feature of the iris dataset. Each histogram visually shows the distribution of values for that feature. The x-axis represents the feature values and the y-axis represents the frequency count of observation within each bin. The use of KDE equals false means there's no smooth curve overlaid on the bars. The histograms provide a quick visual summary of the data distribution for each feature. The image shows 4 histograms, one for each of the 4 numerical features in the iris dataset: sepal length, sepal width, petal length, and petal width. Each histogram displays the distribution of the corresponding feature. The x-axis represents the measurements in centimeters and the y-axis represents the frequency count of data points falling within each bin. By looking at these histograms, one can get a sense of the distribution of each feature, whether it's roughly normally distributed, skewed, or has multiple modes or peaks. This information is useful for understanding the characteristics of the iris dataset and can inform decisions in further data analysis or model building. The code generates a scatter plot using the Seaborn library in Python. The plot visualizes the relationship between sepal length and sepal width for the iris dataset, with different colors representing different species of irises. The resulting scatter plot shows the relationship between sepal length and sepal width for the 3 iris species. Each point represents a single iris flower. The points are colored and shaped differently according to their species. Setosa, likely represented by blue circles. Versicolor, likely represented by orange crosses. Virginica, likely represented by green squares. By examining the plot, one can visually assess if there's a correlation between sepal length and sepal width and whether the different species cluster separately in this feature space. The plot helps to understand how these 2 features can be used to distinguish between the different iris species. The image shows a pair plot generated using the Seaborn library in Python. This pair plot visualizes the relationships between all pairs of features in the iris data set. In summary, this pair plot is a powerful tool for exploratory data analysis, providing a multifaceted view of the iris datasets, features, and their relationships. Seaborn generates a heat map visualizing the iris datasets correlation matrix. Color intensity and numerical values within the heat map represent the strength and direction of correlations between features, aiding in feature selection and understanding dataset relationships. In summary, this code efficiently generates a visually appealing and informative set of histograms for the iris dataset's numerical features, making it easy to compare their distributions. The histograms provide a visual summary of the distribution of each feature, revealing potential patterns and characteristics of the iris dataset. The bimodal distributions of petal length and width are particularly noteworthy and suggest the presence of distinct groups within the data. This information is valuable for further analysis and model selection.
Thanks for watching.